discuss about the shift micro operations. Shift micro operations. So, what do you mean by the shifting? Let us consider, that is, there is an example 1011. This is the data within the register. To move the bits within the register towards the left side or towards the right side is known as the shifting. That is, suppose the 1 bit is here and 0 bit is here and 1 bit is here and 1 bit is here. This is known as the left shift. Left shift. In the same way, suppose the 1 bit is here and 1 bit is here and 0 bit is here and 1 bit is here. This is known as the right shift. That is, the data within the register is moved towards the either left side or right side is known as the shifting. What is the use or purpose of the shifting? By using the shifting, we are going to be transfer the data from one circuit to another circuit in serial manner. That means bit by bit manner. We are going to be transfer the data one bit after another bit. This is known as the serial transfer. This is known as the serial transfer. And also the shifting is also used in some other data processing operations. Data processing operations. Hence, first of all, we would like to know about the what are the different types of the shifts. Different types of the shifts. There are three types of the shifts. One is a logical shift. The second one is a arithmetic shift. The third one is a circular shift. So the first one is the logical shift, the second one is the arithmetic shift, the third one is the circular shift. Either we are going to be perform any kind of the shifting operation, right? Suppose let us consider this is the register. There is a some data to perform the left shift operation. Some inputs are given. Inputs are given from the right side. In the same way, to perform the right shift operation, we are giving or we push the data giving input from the left side. Hence, finally, there are three shifts. Each shift is again divided into the two parts. That means the first one is we are going to be represented like that. The first one logical shift is represented as right SHL. That means I'm going to write in the register transfer notation R1 is replaced with SHL of R1. That means the content of the register R1 is left shifted one bit and R1 is replaced with SHR of R1. The content of the register R1 is right shifted one bit. This is the logical shift. The second one is the arithmetic shift. Right? I am going to write R1 is ASHL of R1. The content of the register R1 is arithmetically shifted one bit left and R1 is replaced with ASHR of R1. The content of the register R1 arithmetically shifted to the right one bit right. So this is the arithmetic shift. The third one is the circular shift. R1 is replaced with CIR CIL of R1. That means the content of the register R1 is shift left one bit circularly. In the same way, R1 is replaced with CIR of R1. The content of the register R1 circularly shifted one bit right. This is the thing. So how this, first of all, the logical shift will be implemented. Let us consider the register. I am going to be implementing the logical shift. I am going to be consider this is double one double zero, right? Let us consider this is the content within the register. The register is R1. Now I am going to apply the first operation, right? SHL of R1. That means left shift one bit. Now the first one comes out of the register. Now that means the output is like that. The first one comes out of the register, so that is vanished. The next one 1 0 0. Here the input is the 1 0 is added at the rightmost side, that is left shift of R1. In the same way, suppose the right shift means actually logical right shift means, we know that this is the, I am going to be insert a 0 from the left side, hence 0 double 1 0. The last 0 is comes out of the register R1, hence it is not available. That is the circular logical shift right and shift left. Now I am going to be discuss what is the arithmetic shift left and shift right. Let us consider in arithmetic shift left and shift right. Again I am going to be consider the register R1 consisting of double one double zero. Now, generally, we are evaluating the value of this R1 in decimal number. 2 to the power of 0, 2 to the power of 1, 2 square, 4, and 2 cube, 8. 8 plus 4, this value is 12. Arithmetic left shift of 1 bit is increase the value of the register 1 multiple by 2. Now I am going to be consider arithmetic ASHL of R1. Now the 1 is here, sorry, the 1 is here and this one comes here, 0 0 and a new 0 is added. What is the value of this one? That is 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube, and 2 to the power of 4. This is 16 plus 8. This is the 24. One bit of arithmetic left shift increase the content of the register multiplied by 2. Again I am going to be perform again left shift of arithmetic ASHL of R1. Again 1 is here, 1 is here, 0 0 0 and one more 0 is inserted. Now let us consider this is 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube, 2 to the power of 4, and this is the 2 to the power of 5. 2 to the power of 5 is 32, 32 plus 16, that is equal to 48. We can observe that for each and every left shift, the value of the register is multiplied by 2. Suppose we are going to be perform the same thing right shift, then the value of the register is divisible by 2. I am going to write ASHR of R1. I am going to cancel this one. The last 0 goes out, that equal to double one triple zero. So the last 0 is vanished. Now we know that this value is 24. Again I am going to be perform ASH of R1. Again, right, the value is double one double zero. This 0 goes out, right? Now the value is 12. Suppose again I am going to perform one more right shift ASHR of R1, that equal to double one zero. This 0 goes out, this value is 6. We know that again I am going to be perform ASHR of R1, that again double one, this 0 goes out, that is value 3. So arithmetic right shift divis- is caused content of the particular register divisible by 2, and arithmetic left shift is caused to multiply the content of the register by 2. Again I am going to be discussing about the circular shift. So the circular shift is a special case. That means we are going to rotate the data within the register without loss, either from left to right, right in this manner, or right to left, or that means or in this manner, right? So here the data cannot be lost in a circular shift. After we are going to be perform n minus 1 shifting operations in left shift, the original data is preserved. That means the original data is intact. But when we know that actually we know that in the register the leftmost bit is considered as a sign bit. So we know that this is a sign bit. Then the data or magnitude sign cannot be changed. Hence, when we are performing the circular shift, the sign bit is applied itself, and only the magnitude is changed from um, most significant bit to the least significant bit, or least significant bit to the most significant bit. For example, let us consider the data in the register R1 as R1 equal to 1101. Right? I am going to perform circular left shift of R1. Now this value, this 1 is here, and this 0 is here, this 1 comes to here, and this 1 come this side. That means 1. Again I am going to be perform circular left shift of R1. Again we know that 0 is here and 1 is here, and this one is here, and this one comes to this end. This is the first time, this is the second time actually, right? Again I am going to be perform the one more circular left shift of R1. That is again 1 is here, 1 is here, and 1 is here, and 0 is here. That is the third one. Again I am going to perform the circular left shift of R1. Again 1 is here, 1 is here, 0 is here, and the last one comes this side, right? 1 is here, this is fourth one. That is after completion of the n minus 1 shifts, that is 4 bits are there, sorry, I'm going to say n minus 1. After completion of the n shifts, the data is preserved. That is, this is also, we can observe that this is the original data. This is the original data. So the circular left shift is the same, sorry, the circular right shift is also the same like left shift. Now again I am going to consider the content of the R1 is 1101. I am going to perform the right shift, circular right shift of R1. Suppose this is the smaller, that is that equal to, right, the 0 is here, and 1 is here, and 1 is here. The last one come to this side, that this is the 1. In the same way, one more time I am going to perform right shift. Again the 0 comes to this side, actually 0 is here, triple 1 is here. In this manner we are going to be perform the arithmetic, logical, and circular shift operations. I hope you can understand. Thank you.